All right, this is for week 3 of CSE212 interview questions, also week 3. The interview questions this time, there are 2 of them. For the first question, it was describing how I would write a function to find the intersection of 2 sets, and that the solution should not use the built-in intersection method. So overall, what I would do is I would convert one set into a lookup structure, and then we iterate through the other set, and then we keep only the items that exist in both. So that's how we're going to be tackling it. And the step-by-step for this one is, and how I think about it, is that first we take the first set and put all its items into a data structure like a hash set, so I can look through things up super fast. Then I'd create an empty result set to hold the items that are in both sets. After that, you loop through every item in the second set one by one. And then for each item, so making again that loop, then that's what we'll check it if this item exists in the lookup structure from the first set. And if it does, you add it into the result set. And then finally, when you have all of those results, you return the result set, which now contains only the items that were in both original sets. And just kind of like before we get there, there's the time complexity, performance, and stuff. And so in order to do that, we're just going to use constant time again, and we're going to do using two variable sets. We're going to go when O is the first variable will be n as in the number of elements in set number 1, which is the one we'll be checking against, and then m is that second set. So it'll be a complexity of O to n plus m. And breaking down that, so we're going to be iterating just like we said, and the complexity of that is just going to be O to n, again, because we're only looking at the one set. And then that's going to be what gets us through it. And so the first test case that we have is just a basic intersection. So let's just assume that set 1, the one we're checking against, has the numbers 1, 2, 3, and 4 in it. And then set 2 has 3, 4, 5, and 6. So the expected result is that in both sets, the only ones that it should return that they both have in common is 3 and 4. And then when we do that, we're going to loop through set 2. When we get to 3, we check if it's in our lookup from set 1. So since it is, we add it, and then we check 4. And yes, because it's also in there, with that, it gets added into the set. But when we check 5 and 6, they're not in set 1, so it gets skipped. And this way, we only add the items that are in both sets. For test case number 2, where there is no intersection, let's say like there's a set number 1 with the numbers 1, 2, and 3. And in set 2, it's only 4, 5, and 6, which gives us the expected result that there will be an empty set returned because there are no numbers in common. And then in the last case, test case number 3, when there's a complete intersection, this is when both sets are the exact same. So set 1 is set to 1, 2, and 3, and set 2 is 1, 2, and 3. The dialogue is going to be that because they're identical, as we loop through every single set in set 2, every single element matches what's in 1. So all 3 elements will be added, and then so that means that the entire set is in the intersection. And that should be it for the first question. And section 2, the question is describing how you would write a function to find the union of 2 sets, and that the solution should not use the built-in union method. So overall, the idea and the approach here is that we're going to add all items from both sets into a single result set. And since sets only store unique items, duplicates are automatically handled. So for example, the first step we're going to be doing to start this off is to create an empty result set that will hold all the items. Then we'll create a loop through every item in the first set and add it to the result set. Next, you loop through each item in the second set and add it to that result set as well. And then because we're using hash set for the result, it'll automatically reject duplicates. If it's an item that's already in the result set, adding it again does nothing. And finally, we return the result, which contains all unique items from both sets. And so basically the time complexity on that one, very similar to what we did in the first question, where it's going to be a big up performance of n plus m, where n, the letter n, as in Nancy, is going to be the number of elements that are in the first set, and m is the number of elements in set 2. And again, the breakdown of that is that we're going to be iterating through sets 1 and adding the result. And then we iterate through set 2 and add to the result. Each element will be added once, and so that's just O to the 1 as an average, and each element is added in the second one, O to M, which means each element is checked and added and then added average for unique items. And the space complexity on that will just be the big O to N plus M again. In the worst case, there's no duplicates. The result contains all the elements. In the best case, where everything is the exact same, the results contain exactly everything that's in common, but no duplicates yet again. And so the test cases for that, we're going to start with first case where every basic union has a little bit of an overlap. So set number 1 will contain the numbers 1, 2, and 3. Set 2 is going to contain 2, 3, 4, and 5. And the expected result that we'll get back is that 1 is a unique number, 2 is there because it's in both sets, but we're only going to add it once since we rejects the duplicates. Number 3 as well is in both sets, but it will only show up once in the result. 4 will show up and 5 will show up as their unique numbers in set number 2. And test case 2, where there's no overlap, similar to what we saw in the other examples, it's the numbers in set number 1 will be 1, 2, and 3. In set 2, there'll be only the numbers 4, 5, and 6, which results will get us the unique numbers of 1, 2, 3, 4, 5, 6. All of them are unique in the cases where they get added to the new list, since they were not seen in any of the other ones. And then test 3 is the complete overlap. So once again, this is the opposite of like what we normally say, where we're adding only things that are unique. But in this case, since all 3 numbers and set number 1 is 1, 2, and 3, in set 2 it's the same 1, 2, and 3, then that means we will get exactly the bare minimum to both, saying that all of them are the same 1, 2, and 3 in the expected result. And with that gives us 3 test cases for each of the questions. Thank you again for the time, and that will just finish up the 2 interview questions that I have for this week. Thank you again.